Hello everyone, welcome to Concepts in Chemistry YouTube channel and also welcome to the Chemistry Concept Booster series. So today in this video we'll be discussing a very important and also conceptual question from a chemical equilibrium chapter. So yeah, let's start without any delay. So Chemistry Concept Booster question number 33. So this question is from chemical equilibrium chapter. So this equilibrium reaction is given. So this ammonium carbamate solid uh, equilibrium with 2 moles of ammonia and carbon dioxide gas. So questions says that in a closed container the above equilibrium takes place. So this equilibrium takes place in a closed container if ammonia gas added from outside. So this is the equilibrium takes place in a reaction in a closed container if ammonia gas added from outside to the equilibrium. So if we add ammonia gas from outside to this equilibrium, then the partial pressure of ammonia gas now, so now means the current, or after adding ammonia gas, so the partial pressure of ammonia gas now become equal to the total pressure in absence of added NH3 gas. So yeah, please read the questions again. So at least 2-3 times you have to read the question. So let's read again the question. So in a closed container the above equilibrium takes place. Okay, if NH3 gas added from outside to the equilibrium process, so this is the equilibrium reactions taking place in a closed container. Now we are adding ammonia gas from outside, that is excess ammonia gas. So the condition is after adding NH3 gas, the current partial pressure of the ammonia gas, so now means the current, or yeah, after adding ammonia gas from outside, the partial pressure of the ammonia gas become equal to the total pressure in absence of added NH3 gas. So if we consider this equilibrium, there is some partial pressure of ammonia gas, partial pressure of CO2 gas. There is some total pressure of these two gas. So after adding ammonia gas from outside, the current partial pressure, yeah, when we are adding ammonia gas from outside means the equilibrium gets disturbed. So the partial pressure of ammonia gas and CO2 gas also changed if we add ammonia gas from outside, because to maintain the equilibrium constant, the partial pressure will change when we add uh, either CO2 gas or ammonia gas. So in this case they are talking about addition of ammonia gas from outside. So now after addition of ammonia gas, they mention here the partial pressure, that is the current partial pressure, or after adding ammonia gas the partial pressure of the ammonia gas become the total pressure. So before adding ammonia gas, there in the equilibrium there will be some total pressure. Total pressure means the partial summation of the partial pressure of the ammonia gas and CO2 gas. This is solid, so no need to consider this solid species. You have to consider only the gaseous species. So before adding ammonia gas, there is some total pressure of the gaseous species. So after adding ammonia gas from outside, the partial pressure of the ammonia gas now become the total pressure, that is previous total pressure of these two species. So the question is that the ratio of total pressure after adding ammonia gas and before adding ammonia gas is. So there is some total pressure. We know that this is a equilibrium reactions. There is some partial pressure of ammonia gas or CO2 gas. If we calculate the total pressure means, then we have to add the uh, partial pressure of these two gases, that is the total pressure before adding ammonia gas. Now we are adding from outside ammonia gas. Now the whole equilibrium become disturbed. So the equilibrium gets disturbed. Now the partial pressure of ammonia gas and CO2 gas, that is previously we calculated, those partial pressure become changed. So now the changed partial pressure of ammonia gas is equal to the total pressure of these two gaseous species before adding ammonia gas. So yeah, I think it seems like complex. So let's discuss the answer. Then I think it will clear to all of you. So this is the questions. This is the equilibrium reactions taking place in a closed container. We are adding ammonia gas to this equilibrium mixture from outside. Condition is after adding ammonia gas, the new partial pressure of ammonia gas become the total pressure of the gaseous species when we are not adding ammonia gas. Means initially the total pressure of the gaseous species become the become equal to the partial pressure of the ammonia gas after adding the ammonia gas to the reaction mixture. We have to calculate the ratio of the pressure, total pressure means the total pressure of the gaseous species after adding NH3 gas and before adding NH3 gas. So these are the options. Let's discuss the uh, answer details as much as possible. So yeah, now I think it will be clear. So let's discuss. This is the equilibrium solid gaseous gaseous. So before adding ammonia gas, now we are considering this equilibrium. There is no addition of ammonia gas. So yeah, before adding ammonia gas means we are not considering the addition of ammonia gas from outside. Now we are considering the only this equilibrium. So let X be the partial pressure of CO2 gas. So see the series equilibrium. This solid ammonium carbamate dissociates to form 2 moles of ammonia gas and 1 mole of CO2 gas. If the partial pressure of CO2 is X, means P of CO2 is X, then in this equilibrium, P of NH3 becomes 2 times of partial pressure of CO2. In this equilibrium, the gaseous species CO2 is 1 mole and this solid dissociates into uh, two gaseous species. One is ammonia, that is 2 mole, and 1 mole of carbon dioxide. So if the partial pressure of carbon dioxide is X, if we assume X, then the partial pressure of ammonia become 2 times of carbon dioxide because in this equilibrium conditions, 1 mole of carbon dioxide is present and 2 mole of NH3 is present. So the gaseous species are 2. Among these two gaseous species, 1 mole of CO2 is present and 2 mole of NH3 is present. If X be the partial pressure of CO2, that is P of CO2 is X, then P of NH3 should be 2 time into X, means 2 time into P of CO2. 2 moles, 1 moles. So the partial pressure of NH3 is 2X, means 2 time of partial pressure of CO2. See here, 2 moles, 1 moles. Now total pressure at equilibrium. In this equilibrium, total pressure is partial pressure of NH3 plus partial pressure of CO2. So 2x, that is partial pressure of NH3 plus partial pressure of CO2, that is x. Total 3x. If we calculate the equilibrium constant Kp, since these are gaseous species, that's why we are calculating Kp. And for solutions, we for solution case, then we have to calculate the Kc, concentration equilibrium constant. Here this is pressure equilibrium constant. So there is active mass. A is the active mass. So whole square NH3 means that is 2 is there. A active mass of CO2 gaseous species divided by active mass of ammonium carbamate solid. A is the active mass. We all know the active mass of any solid is taken to be unity. We all know that the active mass or activity of any solid is uh, taken to be as unity, means 1. So and also we know for gaseous species, active mass can be replaced by their partial pressure. So see, in gaseous species we can replace the active mass by their partial pressure. In solution case, we can replace the activity term by concentration. Concentration if the solution is dilute. In this case, we are replacing that activity term by the partial pressure term since we are considering the gaseous species. So now from these equations, we can write Kp is equal to this active mass of ammonium carbamate solid become 1, means unity. So we can write partial pressure square of ammonia gas into partial pressure of CO2 gas. So the partial pressure of ammonia gas, we know that is 2x. So 2x whole square into x means 4x cube. This is the value of Kp. This calculation is we are considering before adding NH3 gas from outside. Just we are considering the equilibrium in a closed container, and we calculate the partial pressure of each of the gas. Since CO2 gas is present 1 mole and ammonia presents 2 mole, that's why if P of CO2 is x, then P NH3 become 2x. We calculate total pressure. Total pressure means in this whole reaction mixture only these two gaseous species are present. This is solid. So we have to consider the pressure of total by considering the partial pressure of the gaseous species. It's become 3x. So before adding NH3 gas, the partial pressure, the total pressure at equilibrium is the summation of the partial pressure of the two gaseous species, means ammonia and carbon dioxide. So the total pressure become 3x, where x is the partial pressure of CO2. This is the total pressure before adding ammonia gas from outside, and this is the Kp value, that is 4x cube, where x is the partial pressure of CO2. Now let's see the second case after adding NH3 gas. So now we are adding ammonia gas from outside to this equilibrium, and now the equilibrium gets disturbed. So since we added ammonia gas from outside, the partial pressure of ammonia gas and as well as the partial pressure of CO2 gas become changed. Why? Because the Kb value, this Kb value is constant. This Kb value for this reaction is constant. If we are adding ammonia gas from outside or CO2 gas from outside, then the partial pressure will be changed, but the Kp value, that is the equilibrium constant value, it will remain constant. To keep this Kp value constant, since we are adding ammonia gas from outside, the whole partial pressure, the partial pressure of ammonia gas as well as the partial pressure of CO2 gas become changed in these new equilibrium conditions. So there is a new equilibrium. There is a new equilibrium formed after adding of NH3 gas, but the Kp value remain constant. The Kp value remain constant. To keep the Kp value remain constant, the partial pressure changed itself to keep the pressure equilibrium constant value constant. So now we are adding from outside ammonia gas to this container now. And in the question they mentioned this, after addition of NH3 gas from outside, the new partial pressure of this equilibrium or of this reaction mixture of the whole container, the partial pressure of ammonia gas become the total pressure of the gaseous species before adding ammonia. See, we calculated here, this whole calculation is before adding ammonia gas. So we calculated here total pressure at equilibrium is 3x, where we consider x as partial pressure of CO2. So total pressure at equilibrium is 3x. In the questions they mentioned that now the partial pressure of NH3 gas now become equal to the total pressure in absence of added NH3. So in absence of added NH3 means before adding NH3, the total pressure at equilibrium is 3x. If we consider the partial pressure of NH3 gas after added NH3 from outside, after adding extra NH3 gas, if P prime, small p prime NH3 gas is the partial pressure of NH3 gas after adding NH3, means when we are adding NH3 gas from outside, now the partial pressure of NH3 gas becomes changed. If we consider this small p prime NH3 gas is the new partial pressure, so it should be equal to the P. This capital P means the total pressure before adding NH3 gas from outside. Total pressure of the gaseous species at equilibrium before adding ammonia gas from outside. So in the question they mentioned as this P small p prime NH3 gas mean new partial pressure of ammonia gas is equal to P. So we calculated there P is equal to 3x. Total pressure is equal to 3x. So P prime NH3 gas, new partial pressure of NH3 gas become capital P, that is equal to 3x. Also the partial pressure of CO2 in this new equilibrium also become changed. So if we consider the partial pressure of CO2 after adding NH3 gas from outside, the partial pressure of CO2 is Y. They mention the new partial pressure of ammonia gas would be equal to the total pressure before adding ammonia gas, that is 3x. Now they are not mentioning any data about the CO2 gas. So we have to consider the new partial pressure of CO2 gas is Y. So we assume here the new partial pressure of CO2 gas after adding NH3 gas in that reaction container is Y. So at new equilibrium, total pressure like similar new partial pressure of NH3 gas plus new partial pressure of CO2 gas. So new partial pressure of NH3 gas is 3x. We calculated here, and new partial pressure of CO2 gas is equal to Y. So this is the new total pressure at new equilibrium, means after adding NH3 gas from outside. So Kp, if we want to calculate the Kp become P prime, that is the new partial pressure of NH3 gas. Likewise similar, this is only P square P CO2 gas. In this case, P prime. P prime is the new, or after adding NH3 gas from outside, the new partial pressure, or after adding NH3 gas, the partial pressure of ammonia and partial pressure of CO2. This should be P prime. So P prime NH3 whole square and P prime CO2. This should be P prime. So we saw here that the P prime NH3 gas, partial pressure of ammonia gas after adding NH3 is 3x. So 3x square into Y. So it's become 9x square into Y. And we know that Kp value in this whole, we are adding ammonia gas from outside or carbon dioxide gas. If we disturb the equilibrium, but that Kp value, the equilibrium constant value remain constant all time. So the Kp value from the previous case, we calculated the value of Kp is 4x cube. Now if we put this value 4x cube in place of Kp, then we obtain the value of Y as 4x upon 9. So from this calculation, Y is equal to 4x by 9. Now the total pressure after adding ammonia. This is the total pressure after adding ammonia. Total equilibrium pressure after adding ammonia, that is P prime, capital P prime is partial pressure of NH3 gas, new partial pressure plus new partial pressure of CO2 gas, that is 3x plus Y. So just 3x plus, in place of Y we are writing here 4x by 9. We just calculated the value of Y is 4x by 9. So we are putting here the value 4x by 9, that is 31x by 9. So the ratio of total pressure after added NH3 gas and before added NH3 gas should be, so P prime, capital P prime is the total pressure after adding NH3 gas, and P is the total pressure before adding NH3 gas from outside. So P prime is 30x upon 9, and we calculated the total pressure P in before adding NH3 gas, that is 3x. So if we calculate this, it's become 31:27. So yeah, this is a very conceptual questions from chemical equilibrium. I hope you guys understood this whole calculations. So if the question is like that, the ratio of the total pressure before adding NH3 or after, then this will just opposite, that is 27:31. So I think you guys all understand that uh, main things, that is equilibrium. Now in this case we are considering this whole equilibrium to calculate the partial pressure, total pressure and Kp value. So in this equilibrium, 2 mole of gaseous phase presents in NH3 and 1 mole of CO2 presents. So the total pressure should be the partial pressure of NH3 and partial pressure of CO2, summation of. Since 1 mole of CO2 is present, if we consider X as partial pressure of CO2, then P NH3 should become 2 times of P CO2, since 2 moles is present. So total pressure before adding NH3 gas is partial pressure plus partial pressure of CO2, partial pressure of NH3 become 3x. Kp, these activity terms. So you all know the activity term of solute is taken, we normally use assumes as unity the activity of solid, any solid. And we also know that for gaseous species we can replace the activity term by their partial pressure term. Now this Kp become partial pressure. Just we are writing here in place of A the partial pressure term. So it's become 4x cube Kp, that is pressure equilibrium constant for this equilibrium reactions, 4x cube. Now we are considering the second case when we are adding NH3 gas from outside. When we are adding NH3 gas from outside, the whole equilibrium will change, so that the equilibrium gets disturbed and the partial pressure of the two gaseous species becomes changed. They mention on condition that the new partial pressure of NH3 gas become the total pressure before adding NH3 gas. That is P, and that P is 3x. We calculated earlierly. So the partial pressure P prime, small p prime NH3 gas, new partial pressure of NH3 gas become 3x. If we consider the new partial pressure of CO2 gas is Y, then the new total pressure at equilibrium is partial pressure of NH3 gas new plus new partial pressure of CO2, it's become 3x plus Y. Now if we want to calculate Kp, it's become P prime square NH3 gas into P prime CO2 gas. So P prime is 3x square into Y, and we all know from the previous calculation the Kp value is 4x cube. If we want to just we are putting the value of Kp here. From this calculation we obtain Y is equal to 4x by 9. Now P prime, capital P prime, that is total pressure after adding of NH3 gas, it's become 30x upon 9. So the ratio of total pressure after added NH3 gas and before added NH3 gas is capital P prime is to capital P 30x upon 9 into 3x. It's become 31 is to 27. So I hope these questions will help you a lot to improve your concepts in chemistry regarding chemical equilibrium, kind of questions. So I hope you all understood. If still there is any doubt, please comment in the commentary box, so that we can uh, solve your doubt. So thank you for watching. That's all for now. Yeah, bye. Stay safe, stay healthy.